Hey guys, all right, so I'm going to take this 3 o'clock in the morning session while I cannot sleep as an opportunity to run through a little bit of Hornresp for you guys, so you can call this Hornresp 101, and this is going to be for the absolute newbro. So if you've never worked in Hornresp, or perhaps you have worked in Hornresp and you can't really make out what's what, I'm going to start things off from a really grassroots level, and we're going to try and keep it really simple. So 100% targeted towards people who have never gone through Hornresp or really struggled to understand what's going on with Hornresp. This is pretty much going to be for you guys. Right, so the first thing that you're possibly going to need to try and work out is how do you load a driver. So when you open up Hornresp, you are going to see something very similar to what I have on the screen right now. And you will notice that there's all these new things that you've never seen before, and it's possibly feeling quite confusing. If you come up here to file, there's nothing to load a driver and throw in. You just simply can't collect anything. So the way you're going to get around this is quite simple. Just simply go add, right? By adding a new file, it's going to open up a brand new little template for you, and you can work from this. It's going to be really simple. So how do you go about loading your very first driver? Well, see here where it says SD, come up here and double click in that menu. Right, I'm going to show you one more time. You're going to come up here to where it says SD, and you're going to double click in that menu. Once you've clicked on this menu, it is going to load up a driver parameter list, and you can simply come in here and change these values as you require. So you can start adding in your driver specifications, and as you get through and you're happy that everything's all right, you're simply going to click OK. Right, once you have clicked OK, you're simply going to come up here to File, and you're going to paste a copy driver to database. Right, and I'm going to name this Newbro. Okay, so this essentially is going to be the first driver you've ever loaded, and you're simply going to go copy. Now, whenever you are busy in Hornresp and you want to load that file up, you're simply going to come here to paste, right? And you're going to type in the name of the file that you're looking for, Newbro. You're going to click on that and simply just go paste. There you go. There is your speaker loaded. Couldn't be any more simple, right? So without further ado, let's try and get you guys into trying to understand how to actually go to your boxes. This seems to confuse a lot of people. I completely understand. Like I said, Hornresp is a little bit different to some of the other tools that you might be familiar with. So I'm going to try and help navigate you and run you through your very first box design. We're not going to do anything fancy this time around, but I am going to try and walk you step for step through a whole bunch of different models and go through it with you so you can go play around and experiment, right? So what I'm going to do is I'm going to suggest that you come up here to, let me just delete this quickly. Input Wizard, right? Input Wizard is going to be your absolute friend. It's going to help you a lot, right? So you'll see that there are 4 main spaces. Free space, if you were to imagine the speaker being up in the middle of the air, no boundaries, no walls, no reflections. You could imagine you're going to get the purest measurement off of that speaker. We don't necessarily do that unless you're looking at something like a line array, then we'll take that into consideration. But typically speaking, we will only use in half space, right? Most speaker information is given in half space. So that's what you'll use 99% of the time, and is what most box software will use as well. So use half space, it's the one that works. Quarter space, just to explain it to you quickly, if you were to imagine the speaker now up against the floor, like with half space, but up against this rear wall, that in fact would be quarter space. Essentially the difference now is with half space, we have, rather than sound radiating in a full 360-degree pattern, a half space can only allow that speaker's radiating energy to go in like 180 degrees. So we're cutting a tennis ball in half, and in quarter space, essentially everything is stuck within this space and is forced to go in that general direction. And 8 space is pretty much your speaker in a corner. Now, it might seem intuitive to use those, but it is not necessarily the tool to use. If you guys are doing things like car audio, I'm going to strongly recommend that you use some of the features that are within Basebox Pro. You can actually take your FRD measurement on your ground plane, take a measurement of your car at 2.83 volts, and you can capture that trace and bring that trace back in and modify the cabinet, which a lot of people have no idea that that's even possible, but it's quite a powerful tool. But in any case, so we're going to use half space, guys. 99.99% of the time in all modeling, so stick to half space. Right, direct radiator or horn loaded. Well, because we're going to start off things very, very simple, we are going to kickstart the most common designs that are available and that you'll see, which are going to be things like closed boxes, bass reflex, a couple of different band passes, and one or two more exotic enclosures that you possibly never knew existed. And we're going to click next. Right, so infinite baffle, I just want to explain this quickly. If you were to imagine a really big room, right, and you were to mount your speaker into the wall itself, so in wall speakers, that front panel now becomes the entirety of the wall. That you could almost say is an infinite baffle, right? It's an infinitely big front face on a box. Open baffle is again quite simple. It is a baffle, so in other words, you only have the part that mounts the driver itself, and that could be any given size. Requires a slightly more specific driver, so I might come back to an open baffle, but for now we're going to take the closed box selection because it's kind of like it's really easy. Even if you were to not use the tool, the mathematics to design a closed box with a typical Q of around 0.707 is actually really, really easy. The easiest maths in the world, actually. Right, and then we come to three things: normal, offset driver, and stub. Now, this is where things start to get confusing because a lot of people only think of, just a normal speaker box. Now, suddenly you get presented with all this other information and it can seem quite confusing. I'm going to show you a visual reference as to what each one of these mean. If we were to jump into Fusion 360, this might be a little bit laggy because I seem to be having a GPU error somewhere along the line, but I'm going to show this to you in any case. Right, so I don't have a top on this exact box at the moment, and essentially this is going to be a representation of a closed speaker box. Our speaker is going to go in here. We would obviously have a top on, and this is a normal box, right? And regardless of where I move the speaker, I can put it on any one of these panels. Can you see it's not really going to change anything about that box? It's just a normal square little box. Okay, that is the simplest variation of a closed box that we can possibly do. Now, if we consider what an offset driver is, it might seem a little bit weird, but let me explain it to you like this. Gentlemen, anytime that we are working with any speaker or any box, there is going to be some form of resonance within inside the box itself. As the speaker driver goes forwards and backwards, it is essentially oscillating. Those oscillations will create standing waves which are going to bounce from this panel to this panel and that panel and that panel, and these are all going to be little resonances, of which I will show you. That really can be something that we don't want, right? We don't want resonant boxes. In our ideal world, guys, we want a speaker that's infinitely stiff, infinitely light, infinitely large, with a tremendous amount of cone displacement, and a completely non-resonant box. That would be an ideal world, right? We actually want something almost that's counterintuitive. I just said large, but in a way we want something very, very small, because we don't want anything to fit inside that cone, and we don't want it to beam. And long story, there are a lot of things that we kind of try to avoid, and box resonance 100% is one of those things, right? So I'm going to show you an exaggerated version of that in a bit, but let's explain this offset driver. Right, so we have a box which is 600 by 600 by 600. Now what I'm going to do is I'm going to change the parameters over here, and let's say, for example, we are going to make this box 1200 millimeters tall. Right, now naturally we have, here was one box, 6, 12, we basically doubled in size, right? Now we haven't moved the driver, and if we were to close this top off, you could imagine that this driver is no longer in the middle, right? It is offset from a relative position, and we can actually define that within Hornresp itself. So we basically, if we really wanted to, we could define and move this speaker, let's say for example, to this section over here, right? We essentially are moving the speaker around on the box, offsetting its position. Very, very plain and simple to understand, guys. So an offset driver, essentially we are moving somewhere relative to a position within the actual cabinet itself. Let's go and have a look at a offset driver and a stub. Well, let's say for example, the 600 by 600 was exactly where I wanted the speaker to be, dead bang in the middle. Now what I can do, right, is I, in theory, could move this driver around to any given position in this box. But not only that, guys, here is what I can do, right? I'm going to just hide this sketch here for a second. And I've drawn in another panel here, and I'm going to move this, right? Now, if you were to think of us moving this around here, it would basically give me the ability not only to offset the driver relative to some position, but essentially I can keep the box. Let's just actually move this panel out. You know what, I've made this whole thing one thing, like a silly banana, right? That's not going to help much. Okay. But essentially, what I've done is I've moved, our box is the same size, right? So maybe we want to exploit the benefits of having a really large front baffle, but I need the box volume to be the same as what we had when we were 600 by 600. Actually, let me do this because it will give you the ability and hidden edges, right? So you can see I've moved that panel up. So not only is our box bigger relative to our original box, but our volume, because we have now stubbed one section of that particular cabinet, okay? We are keeping things to the same volume, but we have a different driver face. Now, depending on the type of driver or depending on the type of application, this can be a really cool trick to try and handle some resonances and so forth, right? But again, this is more advanced stuff. We're not going to go down that road right now. So let me just close this off. No, we don't need to save that. And let's jump back in here. And we are simply going to do a normal box design, right? Acoustic lining versus no acoustic lining, right? If you're getting into audio, you absolutely will start to do a lot of reading, and we will talk about some form of lining or material that sits in the box. And invariably, it looks like this white, cloudy, fluffy material. All right, so let me explain to you as brief as I possibly can, right? We can convert acoustical energy into heat, essentially. And the more stuffing we put into the box, you can imagine that the more those fibers, as that speaker is moving, they're all, you know, oscillating against against each other, and essentially that is absorbing some of those pressure waves, right? And the standing waves inside the boxes. Works really, really good. But there is a trick. Different types of materials have different, what we can refer to as coefficients, and it's very hard if you are just getting into speaker box building, especially when you're going to some more advanced designs, something that is like a horn loaded speaker or a transmission line. Modeling with that in your actual design itself could be quite tricky, because you might get a really, really good result by throwing in a certain amount of stuffing within the actual Hornresp tool itself. But in reality, how much of that material do you really need in real life? So what I would suggest to start things off is you are going to do no acoustic lining, right? And hopefully at this stage, you are going to invest in things like a DAT V3 and some form of microphone, so you can actually take some acoustic measurements. And then you can slowly but surely start to apply stuffing into your enclosure and come back into Hornresp and try and see if the ZMA and the FRD measurements start to correlate. And once you start to correlate them, then you can start to understand, hey man, I've put so much material in this position and I'm getting this result. And if I jump back into Hornresp and I compare my no acoustic lining with acoustic lining, this must be the property of the actual material that we are lining in the enclosure. Far easier for you guys to start that way than actually knowing or trying to work out some unknown coefficient. You go buy material and you have no idea what's happening, right? So no acoustic lining. Okay, then the input wizard kind of like summarized everything up for us on all of our selections. So in this particular instance, our specified loudspeaker system is going to be in half space. It is going to be a direct radiator. It is a closed box, normal loading with no acoustic line. Sums it up pretty simple. We are simply going to click next, right? Now we have some form of sketch and diagram. They are going, or Hornresp itself, not they. I don't know who they is. They are. Okay, so you can imagine now that this is going to be loaded up with the Hornresp default driver. Very, very important to remember. Whenever you start something, it's going to load the default driver. in some form of rough cabinet that we have specified so far. Now, it's important to understand that this little red line here is a representation of the actual driver, the rest of this being box. Let's go and click finish. Okay, so I want to in fact go and load some driver, and I'm going to stick with what we have over here. With the Salto going off in the background, we might as well just keep to some Salto product. Paste. Right, now you see here it's given us this little caution, VRC, LRC, SD, something's not right here. I'm going to click calculate in any case because I want to start to save this data, right? And you will see that it's going to bring up our diagram. You'll notice something different. Our red line is actually now larger than this box. And that's basically what it was trying to say to us is, hey guys, the volume of the cabinet versus the length of the panel and the size of the driver, the SD, something's not going to fit, right? It's trying to indicate that you, okay, so how do we go about fixing this? Well, there's two things that you can do. One, if you are familiar with Hornresp, you can come in here and simply start to change information. This is going to relate to box volume, panel length, and so forth. But the way I'm going to try and teach you is you're going to come to Tools, Tools, Loudspeaker Wizard. Now, this is something I want you to practice because it is one of those key aspects where if you say no, you're not going to learn. So if you say yes, you are not going to learn. If you say no, Hornresp unfortunately sometimes will exaggerate resonances. Now, I'm not saying that's a bad thing, but it can certainly throw you off in the beginning. Guys, you literally will, if you want to build a transmission line speaker or a horn-loaded speaker of a given type, the truth is you need to build maybe 20 or 30 different models all around the same type of design for you to really start to grasp what's going on between the relationship of your software and what you're measuring in real life. There is no real shortcut. Okay, so I'm going to click no because I want to exaggerate those resonances all the time, right? Now, if you have a look here, VRC is going to be volume. And you can see as we increase the volume, we can see that our box size is increasing, and we can see it's increasing because it's telling us we are now at 90 liters. And if I come back down again, you can see our liters are becoming less and less, and we are now starting to have a smaller box relative to our speaker, right? So if I make this box 88 liters, you can imagine that this is a very skinny flat box, right? Now we need to fit a speaker in, so perhaps we want to make this speaker, let's say, or the box about, I don't know, 50 deep, right? We can see we have a 88 liter box, right, which has a total volume of 88 liters, and we are 52 centimeters deep. Very important, this is all in centimeters, everything that you're going to be doing, okay? From this mode, you can pretty much see everything about your model itself. So this is what we refer to as our system model. It shows us the architecture of our system, right? So in this particular instance, here is our box, here is our driver. When we go into more models, we might move that driver relevant to something else, and you might find we might have something over here, our driver, something else. Don't worry about that, we're going to jump into it. We can also see the total Q of our system, and we can see other things like power handling and so forth. And you will see very, very quickly, the nice thing about this is you can simply just grab hold of something and move it up and down, and you can see a live response. Now notice we have a red line, and then we have this other slightly darkened outline, right? Every time we save something and we go calculate, whatever we have calculated, like now, this will become the new measurement. So if we come back here to Tools, Loudspeaker Wizard, and I click no again, we are going to reflect off of this, right? So let's say, for example, you know what, I want to try and get a little bit more volume in here, or a little bit more bass extension. What happens if I go to 200 liters? Okay, I've got a little bit boost. My Q is now coming down, and you can see it is referencing to what we saved off of or calculated versus what we're changing now. Okay, now when it comes to things like impedance, right, we can see our impedance curve. We can see our driver's displacement. Now keep in mind that it is saying divided by 10, okay? For a couple of reasons, guys, is we still haven't actually provided much information in this. So what I'm going to do is I'm going to come to other. Now, when it comes to adding in power, this can be quite confusing because there is EG and there's RG. RG is the resistance of the amplifier, and EG essentially is your 2.83 watts. Now you'll see that you can complicate things really, really fast, but just try and stick to it as EG. Okay, so as we turn up power, let me try and get into that corner. You can see now we're at 65 volts, and we can see our cone excursion. Very, very simple. Okay, memory and other. If you want to add, for example, a high pass filter, you can come here into filter wizard. Okay, there's two ways that you can activate this. I'm going to show you this again, right? So we would normally be like this. Okay, you'll see the schematic. You're going to come down to power. You can access the filter wizard from here. Impedance, you can still activate the filter wizard, or what we can do is you come here, tools, right, and calculate, tools, acoustic power, tools, filter wizard, right, and then it'll bring it up this way. Doesn't really matter which way you do it. I prefer doing it the other way because I have the ability to toggle backwards and forwards, right? So if I'm in loudspeaker wizard and I'm here at other already, let's come down here to power and filter wizard, right? Everything is still at my fingertips, and I like working in this menu. I'd actually recommend you work in this menu. So there you go, guys. You have basically created your first ever box. Now, one of the important things that you're going to need to remember within Hornresp is your volumes are going to be your volumes, not including all of your things that are going to go inside the box. In other words, if your driver is going to displace 11 liters and your port is going to displace 10 liters, you need to then make a box which is going to be that 11 plus another 10 liters or 21 liters bigger than what you previously thought. Okay, so it's very, very important to keep that in mind, right? And that essentially is how you design and go about modeling your very, very first box. This being a closed box. Closed boxes, generally speaking, guys, you will want a driver with an EBP that's below 50. How do you calculate EBP? Well, it's a formula between, or a ratio between FS and QES. And anything below 50 typically kind of indicates that it's going to be really good for a closed box. 50 to like 75 and a little bit higher starts to indicate that it's going to be really good in a vented box. And anything above 100 plus is going to be pretty good for horns, 6 order bandpass boxes. There are some discrepancies that allow you to kind of model a driver in boxes that you don't necessarily think they would work in, but that's a whole different story. So have any questions, leave a comment in the comments section, and see you in the next episode where we will be modeling a vented enclosure in Hornresp.